When we look at this block, this is a standard main hydraulic block, and this block here is set up with the manual switch box. So I'll go through the block here, and then at the very end here we'll show you what is specific to the manual switch box, and then I'll switch to the next slide, which is going to show us the difference between the two. So this is a manual standard hydraulic block. So initially, A is the shank down pressure gauge. So this gauge is what's reading the actual shank down pressure. It's typically it can operate for the most part in the field in between 700 to 2000 psi. We noted that we could actually read this pressure on the new cruisers with the actual pressure, where in psi it would read that pressure. So what's on that gauge there will also be available to read in actual psi on the cruisers as well. Typical average is in between, average is in between 900 and 1400 psi, where the real true average is closer to about 1000 psi. So those are where it's the range at which it can operate in the field is quite a large amount, which at that point has made us want to go into what's called auto adjust packing for sensors to actually understand what the seed bed pack is and control this, utilize this pressure to increase and decrease to always maintain that actual packing pressure on lifetime seed bed pack. So then second there is shank up gauge. So I'll maybe move this block up to the front that I got. You'll see that B, shank up pressure, is slightly hidden behind, or quite hidden behind. The reason being for that is that it's what it is in place for is basically for diagnosing. So when we look at this large gauge, we noted that it's for shank down pressure. So to know what's on the other side of the circuit, then we would need to know what shank up pressure is. So it's just knowing what the pressures are on each side of the circuit. So it is a gauge for diagnosing. So always nice to know what is happening on each side of a hydraulics circuit. From there, we have C, wing down pressure. We listed off in the manual slightly different as do not adjust, and I changed that for today because the important part of wing down pressure is that you guys know how to adjust it, and that it's one, set correctly, but also two, to know how to adjust it should it need to be adjusted. So in my mind, it should be factory or dealer set, and that ranges from 150 psi up to 1000 psi, and can be adjusted by a technician. So in my mind, anyone that knows how to adjust it and how to properly adjust it and what they're looking to see for pressure, that's the tool that we need, is to make sure everyone knows how. So I'll come back to that. D is the wing up pressure. It should read 0 unless you're folding the machine. So remember, we had red and green tag lines. They connect onto the front of the block, green going in, which is labeled in, red connecting to out, which is return. So typically, if we're getting system pressure, we're pressuring up the green line, and that takes us to E, which is system pressure. So oil coming down the green tag line will go into the import, which will read system pressure, which then we talked about adjusting that pressure to in between 25 to 2900 psi. And at that point, we know that we can use the actual flow control on the tractor to make sure it's set to constant, but also to make sure we can actually adjust the flow to decrease it so that that system pressure is staying below the tractor's high pressure standby. So the main thing with this is that we want to make sure that it is not fluctuating. So if it's operating in the field and it drops in pressure and then comes back and drops in pressure, it's likely you need more flow. So you have to turn the flow up slightly to make sure it's consistent and solid. I mean, it's the same resource as your heart in your own chest. So you don't really want too many inconsistencies with that. So if the system pressure is inconsistent, we'll see as the day goes on that it is the root of where everything else gets its pressure from. So if it's changing pressure or fluctuating, so is everything else. The back side of that circuit is then wing up. So system pressure is the green tag line. The other side of the circuit is wing up, because you simply move the remote on the tractor one way, it gives you system pressure, unfolds the machine. You move the remote the opposite way, it then pressures up the red line and gives you wing up pressure and folds the machine back up. So in a sense, what we want to make sure you guys know is that those are simply reading the pressure on each side of the circuit again. So when we have system pressure, wing up really should read 0 until you lift. So what it's telling you is that the return couplers or the coupler on the red line is returning back to tractor with no restriction. So it's basically, if you have pressure when you're operating in the field, that for instance, if it balanced out the same as your system pressure, you might even want to go to the back of the tractor and make sure that line is actually hooked to the tractor, because it's then has the same pressure on both sides of the circuit. So if the flow of oil is correct, it should be reading 0 or very close to. So not uncommon to see a slight bit of pressure on it if it's on a standard unit that runs higher wing down pressure. So knowing again, that's both sides of the circuit. So from there we have F, which is a solenoid valve, which activates the seating or the shank down top-up pressure while seating in the field. It is activated with the opener pressure switch. So this solenoid on the side of the block right here is your actual solenoid valve, which is supplying the top-up oil. That's why when we put the openers down with the remote on the tractor, that remote should be set with a timer to come back to neutral, because when you turn the opener pressure switch on, or with the new cruiser, the actual foot pedal switch to give you opener pressure, it's activating this solenoid, which is opening a valve, which is giving you a supply oil from the system pressure to maintain a consistent shank down pressure. That pressure is then adjusted with a shank down pressure adjustment motor. So on this image here, or this block here, you can see I have the PWM in that block. In the actual image up on the screen or in your manual, you can actually see that it's got a gear motor there. And that's going to be operated with that manual switch box, where it had the manual toggle where you increased it by pressing it up. It would simply turn the DC motor in, which would be turning the relief valve in, increasing the pressure. Toggle it down, it turns the motor out, which is turning the relief valve out, which is decreasing the pressure. So the top-up oil comes from the top valve, and the actual pressure is adjusted with the lower one. From there, there's only one more valve on an actual standard hydraulic block. And if you look in your image, or even on the one in your actual manual there, we actually see that there is a valve installed on the top of the block, which is this one here. So that valve does go in on the top of the block. So what we're looking at is that when we activate our system pressure, we talked about having wing fold switches, right? So we had inner and outer. So on the manual switch box or the standard fold drills, we actually only have one true function of actual wing unfold or fold. When you actually hit the wing unfold switch in a standard drill, which is a 3-plex or the machine that folds up like a box, what it is doing is it's activating the solenoid, which is activating this bypass valve. How system pressure becomes so high with low flow is that there is an orifice which is located through the top of this block into port OR2, and that orifice is actually controlling the flow of oil and limiting it down to 2.5 gallons of oil to the actual wing circuit. So that wing circuit can only utilize 2.5 gallons of oil. So At that point, it would be very slow to unfold the machine, right? So that's why we have a bypass valve in place. And when you hit the wing fold switch, it simply bypasses the flow of oil around the orifice to create a high flow of oil to give you the fast wing unfold as well as wing fold. And why we need it for folding up is to take the back pressure and relieve it quicker. So that is going to be only within the actual standard machines. So I have it listed here, not M-fold, and it lists not on M80s in the actual manual, but what that means is not just M80, any M-fold machine. So that is a bypass valve that you will see within those standard machines, and what it's doing is bypassing the orifice to give you a high flow of oil. So I'll just pass that valve around for you guys. To make it into a CT hydraulic block, really the only way to do it is to actually block it off, to force it to go over. So we simply remove that valve out of it, and then we put this blank in here, and it forces the oil to always go off of the actual orifice. So it's limiting the oil, so it always has to go through the orifice to be restricted down to 2.5 gallons of supply oil.